Alrighty then. So today we're going to talk about two-dimensional figures. We've talked already about one-dimensional figures. Those would be a line, array, a line segment. Ever get any? No, that's it. Question?
See, this recording thing, does it record just our voices, or does it record like the screen and everybody and you too?
What?
Like, does the recording thing?
I'm waiting still. You told me to wait. Can I be done waiting before I answer your question?
Yes.
Okay, good. What was your question? I wasn't listening. I was too busy waiting.
Does the recording thing that like records us, does it just record our voices, or does it record like the board and you too?
Unbeknownst to any of you, there is an individual. I couldn't even pull it off. Sorry. I was gonna say there's 28 individual cameras in the room. Each one has their own. Cut to camera 7. No. All it's recording is what you see on the screen and our voices. The microphone's right up there.
So it just heard all of that.
Yeah.
Hacksaw.
No, that I don't think I hit record before he told us about the war injury.
You're missing out.
Right. Sounds like Boy Scouts is a dangerous place to be there, by the way. Anyways, we're going from one dimension into two dimensions and talk about some two-dimensional figures. The first two-dimensional figure we're going to talk about today is a polygon. The stuff on the left are all polygons. The stuff on the right are not polygons. And so the question is, what the heck is a polygon? We need a definition. Nolan? Is not part of our definition. Start over.
Polygon is...
That's a good start.
Polygon is a shape
It is. I like it.
that can't have... that has to at least have two lines.
Two lines?
Yeah, two lines.
Two lines?
Two line segments.
Attaboy. At least two?
Yeah, it has to be at least two. It can't be open and it can't be crossed, it can't be rounded.
At least two.
At least two line segments connecting it.
Hold on.
At least three.
Third time's a charm. At least two?
At least three.
At least three. It's a shape that has at least three line segments. Don't write this down. I'm repeating what he said before we revise it. You'll know when we get to a revised definition. And that definition might be rock solid, but I just want to repeat it to make sure I heard it correctly. It's a shape that has at least three line segments that can't be open, has no curved sides, and don't cross.
Yes.
I'm a little iffy on the don't cross thing. What do you mean by don't cross?
Intersect.
Okay.
Like the hourglass one up there.
Do these not intersect? They don't? These two don't intersect? How are we, let's break this down into components. How do we feel about the not open thing?
Yeah.
Okay, so instead of saying not open, we'd want to say that it is closed. Okay, so these are all closed. We're good to go with that. Then you said it's made up of line segments. Are we okay with that?
Yes.
Yeah. Okay, in other words, no curved surfaces. So instead of what it can't be, we're going to talk about what it can be, or has to be. It has to be made up of line segments. The last part I'm a little sketchy on. How are we going to distinguish about these, the difference between these things on the left and this hourglass looking thing that he was talking about? Anybody? What do you got?
I guess you can describe that as saying it has to only have one part to it. Because if you look at like the two triangles, that'd be two parts.
It has only one part. It's better than nothing. I can't figure out why this keeps flashing like this. Give me a second here, kids. We're trying to make. How's that? Oh, much better. Suzanne.
Maybe there can be no vertical angles.
No vertical angles.
Is this a lowest one? I think.
Ooh. Sorry. Just playing with the clicker. No vertical angles. That is true for this particular instance, but not true for others. In other words, I can draw some other things that are not polygons that wouldn't have vertical angles in it, but still not be a polygon. What else? Go ahead, Ben.
It can't have something crossing through the middle, like it can't have a line segment crossing through, like, not the middle, but the inside.
It can't have a line segment passing through the inside.
Sure.
Does that work? These don't have any segments passing through the inside. That one does. This one's a train wreck. That has curves. I don't know, what do you think?
Because what do you think about inside? Using sometimes.
Oh, now they're asking questions that I would ask. So I'll ask, what do you mean by inside?
Like, I don't know. I got it.
Not outside, inside.
Yeah.
Okay. Do we really not know what inside means?
Indoor.
Inside.
Yes.
Side. Inside. Good. I think we all know what inside means, don't we?
Yeah.
Good. All right. Is that okay? It's a shape that is closed, that is made up of line segments.
Should we be writing this down?
Sure. You don't have to do anything. This is America. Fight the bar right on.
Is this like the technical one?
This one, yeah, I guess we're going to call this our definition, so you might want to write it down. It's a shape made, oh, now I lost track. It's a shape that's closed, is made up of line segments, and none of those line segments pass through the inside. Is that what you said, Ben?
Sure.
All right, good. Let's go with it.
Can you repeat the last word?
Certainly. None of the line segments pass through the inside. The inside. Now that we know what a polygon is, we're going to fit polygons into a whole bunch of different categories. The first one would be deciding if a polygon is either convex or concave. I'm going to put up the two fancy mathematical definitions, talk a little bit about them, and encourage you not to write them down because there's a more practical definition. So, first of all, convex. No line containing a side passes through any part of the interior of the polygon.
Write down.
Concave means if a line containing a side of the polygon passes through the interior of the polygon, then the polygon is non-convex, or also known as concave. Does that mean anything to you?
No.
Okay, let's look at these two examples. This is concave, this is convex. The fancy definitions are referring to extending the sides into lines, but here's an easier way to remember. It's concave if
That's cage.
it's caved in on itself. This is caved in. This is not caved in. So you go, pregunta?
Yeah.
See?
Is convex and concave, are those like things to describe a shape, or are those things to describe an angle, or?
Things to describe a polygon. Yeah, polygon, by the way, poly meaning many and gon meaning sides, edges. It's kind of iffy there. Here's where things get a little bit weird. We have convex and concave, but we also have non-convex, which is also known as concave, and non-concave, which is known as convex. So for some reason, people, instead of calling them convex and concave, they want to say, oh no, that figure's non-convex. You mean concave? No, it's non-convex. They're the same thing. Okay, first category. All polygons are either concave or convex. Do that. Oh, there's the $5 you owe me. Can I have that now or Yeah, you need that for medical treatment, sounds like it. How many stitches can I buy for $5?
It depends who's doing it.
That's true.
Dr. Mac.
Could be a guy behind.
I can do it right here for $5. How many you need? Got a needle and thread over there on my desk. We can stitch you up.
I'm fine.
I think you'll be fine. I don't see any saws hanging around in the room.
No clips.
Okay. All right, so then we need to name these polygons. Lauren, what's that purple thing in the upper left-hand corner? It's a triangle. Very good. Excellent. Good job. Let's see. Brian, what's that bright green thing in the upper right-hand corner? Nope. That's a special type of the general name, which is what we're looking for. And it is a quadrilateral. Quadrilateral. Quad, ri, lat, al. Peyton, what's that puke green thing below the bright green thing?
Pentagon.
Beautiful. Pentagon. Pentagon. Jumping over to the boring white thing. Kaylee with a C.
Hexagon.
Beautiful. Hexagon. Hexagon. Let's see where we're going to next. The gray thing. Avery. By the way, 2 possibilities. We'll be impressed if you can get both. Heavy sigh. It's okay if you don't know. It's just basically a Jeopardy question. You either know it or you don't. Or you can make something up. No idea? You don't even want to guess? You don't want to make something up?
Just guess, man.
That is a septagon.
A septagon is correct. Do you know the other name?
That's awesome.
Was that a legitimate guess, or did you hear somebody whispering it?
No, that was a guess.
Wow, that's creepy. The other name is a heptagon. They are both interchangeable. You can call it either thing. What's the red thing, Ricky?
Octagon.
Beautiful. It's an octagon. Stop sign. Don't tell me it's a stop sign. It's an octagon. Octagon.
So why'd you make it red?
I'm sorry?
Why is it red?
Why wouldn't it be red? It's a stop sign.
Exactly.
Right.
It's a-
Why are stop signs red? Hmm?
To alert.
Yes. Correct. What's the yellow thing? Sloan.
I have no idea.
No idea. How many sides, by the way?
9.
9. Anybody know what a 9-sided polygon is? Nolan?
Nonagon.
Nonagon. Nonagon. What's the purple thing, Owen? Want a hint?
Yes.
52 cards.
Did you complete it?
Oh, I totally know it. Oh.
52 cards.
I got
Come
the
on.
text.
Shh. He's a fart smeller. He'll
Oh, I
a
get
smart
it.
feller. He'll fart.
I don't know, I need a phone friend here.
52 cards makes up a what?
A deck.
Ah, boy.
That was great.
The other two that you. That was a really good. Don't do that anymore.
So bad.
You also need to know 11 and 12 by name. Anybody? Bueller? Nolan?
11 is Pentagon.
Nope.
a 9.
Nobody?
Ooh.
Close.
Wait, what are they saying?
Oh, were you guessing, Avery, or were you just making noises?
Yes, sir.
Oh, 11 is an undecagon. Un, 1, deca, 10, 1 plus. Yes, sir?
Moon like the true leader.
Okay, hold on. You're not gonna guess, you're gonna tell me you know the answer.
I think I know the answer.
Undecagon. And what's 12, Avery?
Is it a dodecagon?
It is a dodecagon.
Covered that.
Dio, doe, a female deer. Decagon, Decagon. You need to know 3 through 12 by name. After 12, we don't want to take the time to learn all the prefixes. So I don't want to take the time to teach you that a 52gon is called a dopentadecagon. It's a waste of time. So anything over 12, we just call it the number dash gon. So a 52-sided polygon would be a 52gon. That's it. Seems cheap, but it works for us. What about n? How many sides on an n-gon? N, correct. Don't get an n-gon confused with a nonagon. Nonagon has 9, and n-gon has n. And what is n? N is any whole number greater than 2. The other thing is realize what I just said. N has to be a whole number greater than 2, meaning if you solve a problem and you get the number of sides being 7.5, you did something wrong. It wasn't meant to be funny. But you can laugh if you'd like. Okay, we got that? 3 through 12. More terminology. Equilateral, let's break that word down. Equa meaning
Equal.
equal. Lateral meaning sides, right, equal sides. So the green tick marks on the sides represent this as an equilateral polygon. Equiangular, equa means equal, angular means angle, so equal angles. Yeah, it's really tough. If a shape is both equilateral and equiangular at the same time, we call that a regular polygon. And it doesn't have to be. We will see some shapes that are equilateral, but not equiangular. We will see other shapes that's equiangular, but not equilateral. And we'll see some shapes that are both, which we call regular. We good? Sorry. Wait.
Can you go back for 1 second? Like a little more than 1 second.
Go back.
Can you go back on the screen for 1 second? Okay.
What are you drawing, the rabbit?
I was.
That's
You were?
But I went too fast, sorry.
Yeah.
I'll slow down so you can include the graphics. That's a triangle. John, what does the word perimeter mean?
The distance around the straight.
Good. So if I wanted to find the perimeter of this triangle, what would you do?
You do C.
Sorry, you wouldn't do anything. If I wanted to find the perimeter of this triangle, what would I do? My English just went to heck in a handbasket there, sorry.
You'd add all the sides.
Which would be what?
C plus B plus D.
Well done. John, would you happen to know how to find the area of that puppy?
You do C times D and divide by 2.
Say that again.
You would multiply C and D and then divide by 2.
I'm sorry, that's incorrect. Okay,
You do B times H divided by 2?
good. B times h divided by 2. Base times height divided by 2, or if you prefer 1/2 base times height, it's the same thing. You know this already, right? Good, let's move on. Square. What can you tell me about a square? Right?
All of the sides and angles are congruent.
Which makes it what?
A regular polygon.
What kind of polygon? right? Correct, I mean. What kind of polygon?
Oh. A square? Wait, what? I'm confused what you're asking.
Cassie?
A quadrilateral?
Beautiful, it's a regular
Oh.
quadrilateral, also known as a square. What's the perimeter, Beth?
All the sides added up, or you could just do one side multiplied by 4.
In this case, it would be
S. 4S.
4s.
I was gonna say S squared.
And what's the area, Ben?
Base times height.
Which in this case would be,
S times S.
which is also known as,
S squared.
beautiful. You didn't seem so sure about that one.
I was gonna say 2S.
Oh, then we would have pointed and laughed at you. Pregunta? Sí.
So is it, for the regular polygon, it has to be equilateral and, what's the other word?
Equal angular,
Equally. So this would be,
regular, regular quadrilateral. In fact, it's so cool it has its own name. As opposed to this guy, which is a rectangle. Is the rectangle regular? No. It's equal angular. Look, I got 4 right angles. It's a little hard to see. I put red on purple. That wasn't the smartest move I've ever made. But it is not equilateral. What's a perimeter?
W plus W plus L plus L.
Also known as?
W squared plus
No. Gotcha. What's L plus L?
2L.
2L and W plus W.
2W.
Beautiful. What's the area, Nolan?
W times L.
Lovely. Okay, we good so far?
yeah.
Hot diggity. Like I said, you know that. What's that thing?
Circle.
Circle. We're gonna skip defining a circle because I think you all know enough about it to have an operational Gesundheit, an operational definition, meaning you know enough about it to use it. What's D stand for? Steven?
Diameter.
Great. What is a diameter, Steven?
The distance between the two. I don't know. Never mind.
Go ahead.
Well, I don't know the rest.
We haven't said anything yet.
I said
You
part
said,
of it.
well, yeah, you said the distance, I mean, that, you know. What do you got?
The distance between one side of a circle to the other through the midpoint.
That's not horrible, but there's a couple things we need to talk about. You use the word side with a circle.
One,
Oh, here we go.
there's an inside.
Here we go.
and
Inside and outside.
That's an awesome joke.
I don't know, my dad used to tell me.
That's a good one. So one argument would be a circle has 2 sides,
An inside and
an
outside.
inside and an outside. How many other sides does it have?
No.
None. That's 2. Any other possibilities?
Infinity.
What?
Infinite.
Infinite?
I mean, I just think that a circle would have an infinite number of sides.
Ooh.
Doesn't that make sense?
Okay, let's chew on this for a second. If it has an infinite number of sides, how long is each side?
What?
I'll say it again slower. If a circle has an
Wait,
infinite,
yeah.
Yeah, slow on the circle part especially.
if a circle has an infinite number of sides, how long is each side? Yeah. Nobody?
Number of points. Infinite. Infinitely long.
Infinite? So you're saying all the sides are infinitely long? It'd be a big friggin' circle, wouldn't it?
Yeah.
What do you got?
Each side is infinitely small.
Oh! Oh! And a fancy way for being infinitely small would be, which would be what numerical value?
0.
0. Excuse me for 1 second. So if it has an infinite number of sides, switched into French there for size. Yes, if it has an infinite number of sides, then each side would have a length of, I don't know, maybe 0, huh? Sorry. How is that possible? Well, it's not, or it is. It can't, but it does, but it won't. It will, maybe not. We have, what are we at, 3 possibilities? 2, 1, infinite,
0.
0. 4
We
possibilities.
Never said one.
Never said 1? All right, I'll say 1. 1 side.
One long side.
But isn't a side like a line segment?
Which one is correct? We don't care, let's move on. Back to your definition. You said it's a line segment that does what?
That goes through the midpoint of the circle.
Okay, good, except it's not called a midpoint, it's called a center point. But, you know, we're splitting hairs here. You're dead on. A segment that connects any 2 points on the circle passing through the center of the circle. Well done. In fact, I think that deserves a ball. Excellent.
Can you say that slower?
Certainly. A.
Okay, I got the A.
You got the A, good, good.
Yeah.
Segment. Connecting. Any 2 points on a circle. That.
Wait. I'm doing pictures.
I understand. That passes
Touchdown.
through the center of the circle. Kaylee with a K. What's a radius?
Thank you.
You're welcome.
Half the diameter.
Oh, numerically speaking, that is dead on accurate. A radius is half the diameter. What is it physically, though? If I said to someone, go get me a radius, what are they going to go bring me back? Well, they're going to bring me a diameter and snap it in half. Go ahead.
Distance from the diameter, like to the end of the circle.
Oh, so close. Not the diameter, because the diameter is a segment. The distance from where to where?
The center point to the outside.
Outside?
To the edge of the circle.
If it has an edge, though, that would mean it has a thickness. Does this circle have any thickness? So you're almost there. What should it be? Somebody? Cassie?
Point on the circle.
There you go. Any point on the circle, same thing. Segment connecting the center of the circle to any point on the circle. And yes, the relationship is half of the diameter, or the diameter is twice the radius. In that picture, notice that the circle is the blue part. The brown part is what's called a circle interior. That's not what we're talking about. A circle is like a hula hoop. Please tell me you know what a hula hoop is.
Yes.
Yeah.
Okay, good. What's the word circumference mean?
The distance around the circle.
Distance around. Circles are not polygons. They don't fit into our description because they have curved edges. So therefore, a circle is a circle. Polygons have perimeters. Circles have circumference. Okay? The distance around the outside. And that's found by doing 2 pi r or pi d. And then to find the area, you do pi r squared. Which is a lie. Because pi r round, cake r squared.
Good one.
2 of 27, got that joke.
That was hilarious.
Wait, what?
Oh yeah.
It's a lie. Pi r squared. Pi r round, cake r squared. 3. Don't start.
I'm cut off.
Okay, we good? Yep. All right, beautiful. Let's talk about a dog. I got one right there. We got some fencing and we want to make a dog run. Do you all know what a dog run is? It's a big rectangle that you put your dog in so they can run. Hence the reason it's called the dog run. You'll need your calculators, by the way. Please grab those.
Yeah, I do. His calculator gets all the jokes.
And let's talk about a dog run. Let's suppose you are a sick and twisted individual and you're building a dog run that is 1 foot wide.
Poor dog is gonna like not even be able to.
So, depending on the size of the dog that you have, they could run and then moonwalk all the way back. And then run and moonwalk back. How long, and think before you answer, how long is that dog run?
100 feet.
That is incorrect.
49 feet.
Awesome, 49 feet. Because this would be 1, so that's 100 minus 2 is 98, divided by 2 would be 49. And therefore that dog, that poor dog, would have only 49 square feet to run around it. Are you with me? Now nobody is going to be that cruel,
Wait,
especially if you've got a big dog, because then they would just shade themselves from running up and down the chain link.
Where did you get this?
You could turn around.
Base times height.
Oh.
Okay. So let's suppose we're a little bit more humane, and we make our dog run 2 feet wide,
Oh, yes.
because we have a big fat dog.
Look good.
How long is the dog run?
48 feet.
48 feet. Okay. 100 minus 4 divided by 2, 48 feet, which gives the dog a whopping 96 square feet to run around, and you can see that the area has increased tremendously. We could continue this process by changing the size of the dog run until we see that, like in this case, the pattern that I'm starting here, the area is going up. And at a certain point, I will get to a point where the area starts going down. And I could play this game of guess and check until I eventually found something that I was pretty sure was good to go. However, we don't like guess and check because we're mathematicians. We like to calculate. So we're going to talk about a different way to calculate exactly how big we want this dog run to be, because we want our dog to have the maximum amount of area possible to run around in the backyard. Okay? So, let's start with a more reasonable dog run. Something like this. How long do you want to make that dog run?
25 feet.
Nope.
75.
Nope.
40.
Nope.
10.
Nope.
50.
100 minus 2W.
Wait.
You want to explain that a little bit?
Oh, no, there's stuff we did. We're just putting in that equation.
Yeah.
So, what do you want to call this? W. So, we'll eventually get to what you just said, but that's fairly advanced, so let's shift it into neutral a little bit. What do you want to call this? L. Beautiful. So we're looking at some generic numbers here. I don't know exactly how big I want to make the dog run, but I do know that I only have 9 minutes left, so I'm going to talk faster. How many variables?
2.
2. How many equations do I need?
2.
2, because simple rule of algebra, you need the same number of equations that you have for variables. What's the perimeter of that dog run? Okay.
2L plus 2W.
And what does that equal in this particular problem?
No.
Somebody else take it.
No, you can do it.
It's right over there. It's
100 feet. 100 feet.
100, good.
Let's go.
so damage.
One equation, not solvable. Second equation, what we're looking for is the maximum area. 2 equations, 2 unknowns, should be solvable. So what I'm going to do is I'm going to take this bad boy and solve it for L. If I solve this for L, I get 2L is equal to 100 minus 2W. So L, I'm running out of room here, L is equal to 50 minus W. Now I can take that mess and put it in over here. So area is equal to L times, nope, not L, Wrong. Erase. 50 minus W times W. Does that help at all?
Nope.
Nope. So we got to come up with some way to find the maximum value. I could start plugging and chugging. I could put 1 in, and put 2 in, and put 5 in, and keep plugging in numbers, like I said, until the area gets big and big and big, and then it starts to come down, and then I have to go with that number. But what if the answer is like 7.387? Are you going to realize that you got to plug that in? Probably not. And so again, being mathematicians, we want to be able to solve that. So we're going to use the calculator. Bust out your calculators. Dun, 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 dun. Okay, let's go to y equals. I already had it in there, so I'm going to clear that out. And we are good to go. We're going to put the function in there. So instead of W, you could use W's on the calculator. It's easier to use X. And the button for the X is the XT theta N button. So X times the quantity, 50 minus
what?
X.
X times the quantity, 50 minus X. Got it.
So if I draw a picture of this thing, and I know already it's going to look like a parabola, the top of that parabola will tell me what I want to make my dog the happiest.
Wait, parabola?
That's what I said, parabola. Zoom 6. Oh boy.
Zoom 6?
Zoom 6. Yeah, standard
Whoa.
zoom. That's not good. I can't see anything there. What's the matter?
It just comes up with words.
It just comes up with words.
6. Go to 6.
Zoom 6. Zoom 6.
Ah.
So, the picture is there, it's just not fitting in the window. So I'm going to hit the window button, it's the one that says window on it, and change my scale. What's the smallest value that we could choose for W, theoretically?
50.
0. Really, really skinny dog run. I'm going to put 0 in there. What's the maximum I could choose for the width?
100.
100? That's not right, but we'll go with it. 100, okay. And then Y represents the area. I can't get a negative area, so I'm going to hit 0 in there. The smallest area I could get would be 0. Again, that would be sick. But now you...
I'm having troubles.
Okay, I'll help you in a second. I'm running out of time. I got to get this done. Now I have to guess what I... Kaylee?
Wouldn't the maximum X be like 50?
It would. But we'll go with 100 because that's what they guess, and I'll just show you what happens if you make a mistake. So what do you think the maximum area is going to be when we're done with the calculation guesstimating? 100. Okay. 100. Graph. Nope. So what happened here? It shoots up, and something happens up there and comes back down, so our number of 100 is incorrect. So let's go back down and change that. Gesundheit. 100 didn't seem to be enough. How'd you like to increase that, Ben?
It didn't seem to be enough.
It was
Let's
not.
go 1,000.
What? Oh.
Just adding zeros everywhere.
The gloves are off.
Oh, there.
Oh yeah.
Oh, mine didn't.
So to your point, Kaylee, that is correct. It would only be 50 would be the maximum. But it doesn't matter. We can see what we want. Everybody with me so far?
Yep.
Now we want to find that point. There's a couple different ways you can do it. You could trace along it until you get close and guesstimate, Gesundheit, but I don't want to do that. If you hit the calc button, which is above trace, second, trace, gee, which one do you think you're going to pick?
Maximum.
Maximum, number 4. Okay. Now, this is where you need to understand how the calculator works. The calculator needs you to zero in on what you're talking about. What part of the graph do you want to find a maximum for? Our max is right up there. We have to go to the left of that max and hit enter. So right now I'm at 50, that's no good. I'm going to left arrow over. You see my cursor there. And I'm scrolling, scrolling, scrolling.
Oh,
Keep
I
that
see
calculator scrolling.
That's
Keep
so
that
cool.
thing a scrolling
Thing
till
about-
I'm on the left hand side. For those of you that struggle with left and right, you go like this. Which one's an L? That's your left.
See, I'm on the top.
Hit enter. Right bound, go to the right. Hit enter. Guess. Move over where you think it's going to be. Hit enter. Booyah! For our purposes, 24.999999996 is
Plus 25.
Oh my god, I
I
got it.
have 24.9999997.
I have 24.9999995.
yeah, it's fine. Still
I have
25.
25.0, so I'm still reading.
Cool. Okay, so now that we solved that, look at the two values here. X, which was our W, is 25. What does Y represent? The maximum area. What shape is a dog pen going to be?
Square.
Square. Okay? Beautiful.
Wait, what? What is that?
The answer is that it would be a square, 25 by 25, which would have a maximum area of 625.
Oh, okay.
So we come back here. There is more to the slideshow, but we are running out of time. I'm going to post a slideshow on Schoology. You can finish up with the next couple slides, which are just examples of circle calculations. The answers to 1, 4, and 1, 5 will be up there also. Check that tomorrow. And then we're good to go. If you find yourself having tons of questions on 1, 4, and 1, 5, you need to come and see me. We won't have a lot of time to go over homework tomorrow because I want to get you started on the quiz right away.
Do you have any